Have you ever wondered exactly what a flash of lightning is and why a rumble of thunder follows? Just as bolts of lightning always seek Earth, by the early 18th century scientists had started to puzzle over this and about electricity much closer to home. The ancient Greeks knew that if you rub amber very hard, it attracts small nearby objects to it. Lodestones could also be used to magnetize needles, and by the time of Copernicus in the mid 16th century, crude compasses were being used by seamen to help find their direction, since one end of the movable needle of the compass always pointed to the north. An English doctor named William Gilbert wrote about this in 1600 when the word magnetism had arrived. By that time, a device called Leyden Jar was invented. It was named after the town in the Netherlands where it was invented in about 1745 by a professor at the university. The jar was half filled with water and connected to an electricity generating machine by a wire. The report of this experiment caused a sensation and Leyden jars became all the rage. 10 monks once linked hands, and when the first one touched the jar and conducting piece, they were all jolted simultaneously. An electric shock, it seemed, could be passed from person to person. There were a lot of theories flying about, but one person who brought some order to the subject was Benjamin Franklin. He was a witty, popular person, full of homespun wisdom. Next time you sit in a rocking chair or see someone wearing bifocal glasses, think of him. He invented them both. Do you know who coined the word battery? It was Benjamin Franklin. Like many people in the 1740s and 1750s, Franklin was curious about Leyden jars and what they could show. Further experiments convinced him that the jar's actual power lay in the glass, and he made a kind of battery by placing a piece of glass between two strips of lead. Franklin suggested if two clouds collided with each other as they rolled across the sky during a thunderstorm, there would be a discharge of electricity, a flash of lightning. By flying a kite during such a storm, he could show that this idea was correct. The kite experiment convinced Franklin that the electricity of lightning was like the electricity of Leyden jars. First gravity, now electricity. Things in the heavens and on earth were being brought ever closer together. Franklin's work on electricity had immediate practical consequences. He showed that a metal pole with a sharp point conducted electricity to the ground. Franklin connected a lightning rod on his own house, and the idea caught on. There were important results to be had from understanding electricity. The study of electricity was one of the most exciting areas of scientific research in the 18th century, and many electricians, as they were called, contributed to what we know today. Three in particular have left their names with us. The first was Luigi Galvani, a doctor who liked to tinker with electrical apparatus and animals. He practiced medicine and taught both anatomy and obstetrics at the University of Bologna, but he was also much interested in physiological studies. While investigating the relation between muscles and nerves, he discovered that a frog's muscle could be made to contract if the nerve attached to it were connected to a source of electricity. Electricity was an important part of animals, Galvani said. Indeed, animal electricity, as he termed it, seemed to him to be an essential ingredient of how animals functioned, and he was right. Static electric shocks, which occur when electricity that has built up on the surface of an object is discharged, are still called galvanic shocks. Scientists and electricians use galvanometers to measure electric currents. Galvani's notion of animal electricity attracted a good deal of criticism, especially from Alessandro Volta, a scientist from Como in northern Italy. Volta had a low opinion of doctors who branched out into physics, and he set out to show that animal electricity did not exist. More importantly, Volta discovered that if you built up successive layers of zinc and silver and separated them by layers of wet cardboard, he could produce a continuous electric current through all the layers. Volta sent news of his invention, which he called a pile, to the Royal Society in London. Like the Leyden jar, it created a sensation in England and France. Our third great electrician and formidable mathematician also gave his name to the measurement of electricity, Andre Marie Ampere. We get the word amp from his name. Ampere realized some fundamental things about mathematics, chemistry, and above all, what he called electrodynamics. This complicated subject brought together electricity and magnetism. Despite its complexity, Ampere's simple but elegant experiments showed that magnetism was in fact electricity in motion. Although later scientists showed that many of the details of Ampere's theories did not lead anywhere, he provided the starting point for much research into electromagnetism. It is important to remember that science is also about sometimes getting things wrong. Galvani had the last laugh on Volta, for we now know that electricity plays an important part when muscles and nerves interact. See you next time. Keep tuned.